Good morning everyone. So اليوم حنبلش بتشابتر جديد اللي هو الفورسز تشابتر 12 وهون لازم نلفت النظر انه توزيع الدرس هو بحسب الكتاب الرسمي المعتمد بمركز البحوث. يونت 4 اللي نحن بالنسبه لنا يونت 3 ميكانكس، اول شابتر فيها فورسز. معظم المدارس معظم التلاميذ ممكن يكونوا شافوا هذا الدرس بصف الثامن، رح يكون بمثابه مراجعه للي اخذتوه، وللي مش اخذين الدرس بصف الثامن هيدا انتروداكشن لشو بده يطلع عنا بالدروس القادمه. يلا خلونا نبلش. So chapter 12 forces, we're gonna cover the following points. First we'll define what a force is. We'll talk about the effects that a force has on a certain object. Then, how can we represent a force in a certain situation? At the end, we're going to classify forces, we're going to talk about some types, and we'll focus mainly on a very particular force which is known as the weight. Starting with defining forces, over here we observe a certain figure. You notice that to shoot a basketball or a football, you should always apply some action, and that action sets the ball in motion. So what's happening here? Or in another situation, when you try to stop a ball, the goalie exerts a certain action to stop it. Again, that action stops the ball. In some other situations, for example here, you notice that in a certain accident, the car exerts an action on the car in front of it and vice versa, okay? Thus, we have deformation. So هون الميكانيكال اكشن عمل شيء غير انه عمل موشن او وقف موشن، صار عندنا deformation. In another example, a boy with his fishing pole and the fish on the other side exert some action on the pole here, and that action bends it. It changes the shape as well. So now we have some good ideas about what is common between all the given examples. So شو في مشترك بين هالexamples اللي شفناهم؟ شطنا طابة بمحل، وقفنا طابة بمحل، غيرنا object، شو عم بيصير هون؟ All of these rely on a mechanical action that's producing motion, modifying motion, or even deforming an object. These mechanical actions are referred to as forces. ببساطة شو يعني force؟ تعريف force هي بكل أمان a pull or a push. سحبنا أو دفشنا. Any action of pulling or pushing هو ببساطة a force. Now, effects of a force اللي هلأ ذكرناهم. Okay, when a force is applied on a body, it can produce one of the given 3 or 4 points, which are, it can set it in motion, such as when we talked about shooting the ball. It can also modify the motion, stopping the motion or changing path of motion, such as in the example of the tennis racket. It can also deform the object and change its shape, such as in the example of the car accident. So, this is the effect of a force. We have talked about the definition of a force. Now we have seen the effects of a force. Now we move on to how can we characterize a certain force. Being a push or a pull, so there is an important thing we have to notice about forces. شو هن الأفكار اللي بنحكي فيهم؟ First, any force has a point of application. أي force في عندها نقطة بنحط عليها. For example, a boy here is pushing a box. Now, where is this boy pushing the box? You notice at this point, we call it point of application. The second is the line of action. Now, رح نحكي عنها بعد شوي هي لأنه لغوياً ممكن نستعملها غير شيء. The line of action is the line or the direction, the line over which we apply the force. مثلاً هون هيدا الولد ممكن يكون عم يدفش البوكس هيك. So we say that the line of action here is horizontal. We also can talk about the direction of the force. Direction, some people might say direction, same thing. So, the direction of a force is the orientation on the line of action. يعني هيدا الصبي هون عم بيدفش horizontally، بيسوى يكون عم بيدفش على اليمين أو على الشمال. When you say right or left, this is the direction. Last but not least is the magnitude or the value of the force. So how much effort is applied on the box. قديش أنا عم بحط دفشة. That's what we call the magnitude. To talk about the magnitude, it might be given. فيه يكون عاطينا إياها بالgiven. وبيسوى يكون عاطينا tool لنقدر نقيسها. So when we want to measure the magnitude of a force, we can use a device called the dynamometer or a spring balance. هاو هني. Spring balance مثل الميزان اللي بنشوفه أوقات عند الخدرجة. Okay? Or in such shape. So these are dynamometers or spring balances. And anytime we talk about a force is expressed in Newton. The SI unit of a force, the systematic unit of a force, is the Newton, after the scientist Isaac Newton. Thus, after talking about these characteristics, whenever we represent a force, we need to use a vector. مفروض نكون أخذنا vectors بالمات كان grade 8 أو grade 9. Okay, a vector ونحط اسم الفورس with the arrow on top of it indicating that it has some direction and magnitude and line of action. So when we talked about the line of action here and direction, كنت قلت لكم إنه في remark عنهم. بمحلات معينة, especially in mathematics, you might have used instead of line of action the term direction, ومحل direction نستعمل sense. So ممكن بعض الكتب أو بعض الأساتذة يكونوا مسمينهم direction و sense. مش غلط, المهم إنه يتحددوا بترتيب. For example, إذا أخذنا هيدا اللي عم نحكي عنه, الشاب الصبي اللي عم بيدفش الباكس. Okay, look at the figure here. مثلا, what can we say here? This boy is pushing the box horizontally with a force of magnitude 40 newtons. So, شو هن ال characteristics of the force he's applying? Point of application, هون استعملت اختصار بس لسرعة الشغل مش أكتر. Line of action, direction and magnitude. بنحكي عن كل force لحالها. Okay? Point of application. وين حاطط هالفورس هيدا الصبي؟ Simply هون هو ال contact point بين إيده والباكس. Along which line, على أي خط عم بيدفش. يلي بالgiven إذا بتلاحظوا is pushing horizontally. So هيدا الصبي عم بيدفش direction horizontal. So the line of action is horizontal. Now on the figure, هالصبي عم بيدفش على اليمين أو على الشمال. Pushing horizontally. Pushing, ومن حسب الصورة بنلاحظ إنه عم بيدفش على اليمين. ممكن حدا يجي يقول لي بلكي عم بيدفش على الشمال أو أي شيء تاني. صرنا هون عم نفوت بتفاصيل يمكن ما إلها عازة. So pushing towards the right side. So the direction will be to the right. بضل عندي الماجنتيود هون كتير واضحة. قلنا ال value, the magnitude of the force is 40 newtons. So إذا مطلوب مني كنت جاوب وعبي characteristics, كتبتهم هون وفهمنا كل فكرة شو هي. هون I called it point A just for simplicity as well. You can add it on the figure and show it. Now, how can I represent this force? If you want to represent the force, بدك ترسم هاي الفورس على هيدا الفيجر. كيف ترسمها؟ So, first thing, in order to draw a force, فينا نحدد شيء اسمه scale اللي هو مثل مسطرة لتساعدني ارسم الفورس. ما عندي مسطرة أنا هون, هي عندي مسطرة. ما عندي مسطرة مكتوب عليها نيوتن. Usually when we draw in geometry, we use centimeters, millimeters, meters. ما بنستعمل نيوتن. So من هون بنستعير شيء اسمه scale اللي بيقول لي إنه مثلاً بدي آخذ كل 1 سنتيمتر يمثل 10 نيوتنز. We call it a scale. 10 نيوتن for 1 سنتيمتر. بهاي الحالة هون شو بيصير عندي؟ 40 نيوتن وعطينا سكيل ونحن افترضنا سكيل 10 نيوتن per cent over أو for 1 سنتيمتر. هون ضروري تعرفوا إنه يا بتكون given أو أنت بتقترحها إذا عم بتعبر عن جواب معين. So 10 نيوتنز over 1 سنتيمتر كفراكشن هي ذاتها رح تكون 40 نيوتن over x. هون نستعمل شيء نوع من proportionality إذا متذكرينها من درس الماثماتكس. Anyway, رتبناها بطريقة 10 نيوتن over 1 سنتيمتر 10 نيوتن per سنتيمتر بتساوي 40 نيوتنز الجيفن over x. ما بعرف قديش الx. هلا هون واحد فيه يعملها mental math, ما حدا له معك أكيد. بس إذا حبينا نفرجي الكالكوليشن x equals 40 نيوتنز times 1 centimeter divided by the 10 newtons. Writing this, نيوتنز كانسل اوت بيطلع عندي x equals 4 سنتيمتر. سو بجيب هالمسطرة، هي مسطرة هون، باخذ المسطرة عندي 4 سنتيمتر، هون المسطرة مرقمة بالمليمتر، فينا نغيرها اوكي ونقول له حط لنا اياها بالسنتيمتر. سو اي نيد تو درو على هاي البوينت محل ما هالصبي حاطط ايده بدي ارسم فيكتور 4 نيوتن 4 سنتيمتر سوري 4 سنتيمتر اللي هن بيمثلوا 40 نيوتنز. اوكي ببساطة جينا اوكي ورسمناها. اوكي خلصنا من هي، حطينا اللي بدنا اياه اوكي حطينا اتجاه الفورس، اسم الفورس اف ومشي حالها. اوكي رح نشيل المسطرة هلا. اوكي كيف تبين القصة؟ اذا بتلاحظوا هون بوينت A سميتها الفورس اف مع الفاليو تبعها. اوكي خلينا نروح نشتغل ابلكيشن تنتاكد انه مشي حالنا فيها. So let's start solving this. List the characteristics of this force. So the girl is pulling the toy by a certain force of 20. What are the characteristics of a force? So we know that a force has a point of, first I'm going to name it F, force F. First characteristic is the point of application. Second is the line of action. Third, we have the direction. Fourth, we have the magnitude. Now, so what do you think about each characteristic? What is it? So it's the point of application where that force is applied. Obviously, the girl is holding the toy at this point. So the point of application is the contact point between the girl and the toy. If this point is called or named A, B, C, anything, you can simply use A. The line of action. The girl is pulling the toy behind her. Notice my hand is not horizontal, it's not vertical, it's inclined in between or oblique. So the line of action here is oblique or inclined. Better use the term oblique. Direction, the girl is pulling the toy. Apparently she's running to the left side, so she's pulling upward to the left. And the magnitude, it's given to be F equals to 20 newtons. So straightforward application, nothing to worry about. Now, second part is represent this force. So to represent a force, we need to use a vector. That vector should have some value, some magnitude. That vector will be drawn, sorry for that. It will be drawn at the point of application, it will be drawn oblique, it will be drawn upward to the left, so we have everything here. But we can't draw with 20 newtons. We can't have a ruler with Newton scale. So we have to convert the 20 newtons to some measure. For that, we're going to use the given scale, which is 5 newton per centimeter. Now, as you should have guessed, I guess, 20 newtons and scale is 5 newton per centimeter, it's going to be 4 centimeters. But if you want to show your work, as usual, we go to fractions. So first, we have 5 newtons for 1 centimeter equals 20 newtons for x. The unknown here is x. How can we calculate x? Using simply cross multiplication. X being 20 newtons multiplied by 1 centimeter and divided by 5 newtons to get directly 4 centimeters as you have expected. Now drawing the force, I will draw it aside here, then we'll go up to the figure and check if you want to add it there. So at a point here, I'll suppose this point represents the contact point between the girl's hand and the wagon, which is to that direction. Now the force is oblique. I will draw randomly any oblique direction. And it is upward to the left, so in this sense, to that direction. Now the value should be 4 centimeters. Okay, get my ruler, Here is the ruler. I place the ruler here at the point where I'm going to start the vector, turn the ruler along the line where I expected the direction to be, and on this line I draw a vector which is 4 centimeters. I extended it here a bit by mistake, so here it is. So this is the force F, which is 20 newtons. Now, collecting all these ideas together, first let's move this off the screen. Okay, so here is the answer written and stated. Okay, I've drawn the force here at the point of contact between the girl's hand and the toy itself. Also, the force should be 4 centimeters as well. Now, if you have any comments about this application, I think it's straightforward, but if you have any comments about the application, don't hesitate to refer to your teachers about it. Now, we go to the second section, which is classifying forces. So when we talk about a force, we have to distinguish between two categories. Some forces are forces acting by contact. They need contact in order to be observed or applied. And some others do not need. They act from distance. They don't need to be in contact. For example, of acting from distance, when you have two magnets, a magnet pulls another magnet without being in touch. They can touch each other, but they can be separated. Nevertheless, you can feel. بتضلك تحسون عم بيشدوا بعض. Okay? So what are some examples about contact forces? We have muscular force, any action that you do by your hands, by your body. Friction, normal reaction. We're going to talk about each of these forces if you haven't seen them before. Okay? For example, muscular force is something simple. I expect most of us to know them. Friction. What is frictional force? Anytime we have a certain solid surface and another object placed on it, there might be some friction. Why may be some friction? Okay? If that object tries to move and the surface is rough, خشن, you might expect some resistance against that motion. We call it friction. Place an object on the floor, try to pull it, you notice that that object will not move directly. Okay? It depends on the type of the floor. For example, this boy is trying to push a box. That box is placed on the ground, on floor. Friction acts against him. He's pushing to the left while friction is trying to resist and thus acting to the right. Another example is if we have an inclined plane. Place a box on an inclined plane, that box tends to move down. It tends to. مش ضروري تدفشها، هي بتجرب تمشي. Sometimes it slides down, sometimes it doesn't. What prevents it from sliding is the frictional force acting up. If the box is placed on a horizontal path, just like the boy here with the box, but without anyone pushing or pulling, there will be no friction because there is no tendency to move. البوكس ما رح يمشي. So ليش بده يكون في friction? Friction always acts against sliding, against the tendency to move. Now, another force is the normal reaction. What is the normal reaction? Place an object on a solid surface. That solid surface might break. Sometimes it doesn't. Most of the times it doesn't. I'm standing on the floor right now. The floor isn't breaking under my body. Why? Simply because the floor is pushing against me. So since the floor is holding me, we call that force the force exerted by a solid surface perpendicular to the surface. We call it normal reaction. The normal reaction is represented by a vector here. It's called Rn, normal reaction, or N. Both names are found. Feel free to use any of the two. Another contact force is the traction of a car. I'm not going to draw this because we all know that a car has the engine. The engine exerts some applications, some action so that the car moves forward or backwards. Tension in a string and elastic force. These two forces are going to be seen displayed together. First, let's talk about the tension in a string. A string, خيط, or a rope, حبل, any extended object, أي object مشدود. For example, the guy here is pulling the box by a rope. This rope exerts tension. So tension here is pulling the box in this direction. So the force exerted by the string on the box is called the tension. Over here, the ball is held by a string. The string pulls the ball upwards. We call that tension. The force exerted by the string on the ball. On the other hand, elastic force is the force exerted by a spring, ressort, or an elastic object. بأغلب الأوقات رح نستعمل ressort. But it might be an elastic band, شي مغيطة أو شي object تاني. It might be again. In this situation, for example, here we have a spring and the box attached to it. The spring pulls the box up by a force similar to tension, but we call it here elastic force. As a matter of fact, this type of forces is going to be the subject of an upcoming chapter. رح نحكي عنها بدرس مفصل تقريبا لحالها. Now, how the listed forces acting by contact. ممكن تفكروا بفورس تاني انه اذا انا جيت قعدت بالمي المي بتدفشني لفوق شو بنسميها هي الفورس؟ Think about it. جربوا فكروا فيها. Ask your teacher. ممكن تلاقوا جواب. Now, we move to the other category of forces. Forces acting from distance. We have electric force, we have magnetic force and gravitational force. خلوني أول شيء ركز على electric ومagnetic لأنه لحد اليوم نحن grade 9 electric ومagnetic شوي صعب نفهم الفرق بيناتهم. Electric force is when you have charges positive و negative. إذا مجربين example تاخد بالون حف البالون على راسك وقرب البالون لزقه بالحيط you'll notice that it will stick there. هون في نوع من electric attraction عم تجرب تهدي البالون بس ما رح فوت بالديتيلز تبعها. Let us leave it for grade 10. You will discuss it with your teachers next year in Allah رات. Magnetic force is something more materialistic. بالنسبة لنا شيء عملي أكتر. Magnetic force is a force exerted by a magnet. Okay, now it's a force exerted by a magnet or a magnet. It can be between two magnets. North بيعملوا repulsion, south and south كمان repulsion. بس إذا كانوا north و south بيشدوا بعضهم. So بعتقد كلنا مجربين هذا الاكسبيرمنت هلا من قبل وعطولي بيمرق معنا especially in games. Now, it can also be between a magnet and iron objects. We call these ferromagnetic objects. No need to worry about the name. بس إنه بشكل عام المغناطيس ممكن يشد objects بين الهلالين فيها حديد، نوع من الحديد. In this situation the force is always attraction. على طول المغناطيس بيشد الحديد، ما معقول يدفشوا يبعدوا عنه هيك مباشرة بدون أي شيء تاني. Another force is the gravitational force. هون هيدي force بنوقف عندها شوي. Okay, gravitational force وبشكل خاص نحن بنركز على weight. Okay, so what is weight? Weight is a gravitational force that is exerted by a planet or an object in space on another object placed on it. إذا وقفنا عندها شوي لنحكي عن شو يعني gravitational force. First, gravitational force is a force of attraction between any two objects having masses. Isaac Newton, okay, studied this for a long period of time to explain how planets interact. Okay? Applying this between planets in general is referred to as gravitational force. بس روح قول planet و object على هيدا البلانت بنحكي عنها weight. الأفضل مش بقى هلا أنا عم بستعمل كلمة planet. It can be a planet, it can be a satellite, a moon, أي object حجمه كبير. Any celestial object in space attracts another one. Now, okay, so for example here the famous experiment بس وقعت التفاحة على راسه لنيوتن. What made the apple move down is simply gravitational force pulling it. Okay, the value of the weight لأنه هي من البلانت depends on the planet itself. يعني الويت على الأرض رح يكون غير الويت على غير planet. This is something extremely important ولازم نخليه ببالنا. مثلا هون man having a mass of 60 kilograms on Earth. Mass is the quantity of matter شفناها بgrade 7. His weight is 600 newtons on Earth. The same man goes to the moon, hypothetically speaking, his mass becomes 60 kilograms, remains 60 kilograms, but his weight becomes 100 newton. تغيرت. شو السبب؟ Weight is the pull of a planet or a body on a certain object. هون الأرض عم تشد ب 600 نيوتن، بينما هون القمر لأنه أصغر من الأرض عم بيشد ب force which is 100 newton, less than that of weight. So keep in mind, mass never changes, it remains the same always. What changes is the weight. Now, what we're gonna do next time is to talk in more details about the weight itself. برجع بعيد، ممكن تكونوا شفتوا هودي بجريد 8، اوكي؟ إذا لا نحن عم نشرحهم من الأول، إذا شايفينهم بجريد 8 رح تقطعوا بهو كتير بسرعة ورح كون عم بحكي كتير شغلات يمكن ما لها عازة بالنسبة لكم هلا. ركزنا هون بهيدا السلايد على gravitational force اللي اسمها weight, which is the pull of a planet or earth on an object. Now خلينا نحكي بشوية تفاصيل عنها لأنه قلنا it depends on the planet itself. قلنا أنه الماس خصه بطريقة من الطرق logically بس ما شفنا كيف. So let's move on now to talk about weight in particular. What are the characteristics of weight? Weight has some specific characteristics that never change. بيضلوا هن ذاتهم شو ما كان exercise. These are the point of application. It's always applied on the center of the body. أي object عنده وزنه على السنتر. Okay? My body here. My center is in this area. على طول weight بيشدني من هون. If I take any object, weight will pull it at its center. I have my pen here. The pen. القلم عنده center هون بشي محل. Weight is pulling at the center down. Its line of action, it's always vertical. Weight is always applied vertically. على طول عم بيشتغل نزول، يعني هي التفاحة اللي كانت عم تنزل على طول عم نشدها على هيدا الخط vertical. What is vertical أو الخط العمودي? It is simply a line extending towards the center of Earth. تخيلوا خط افتراضي قاطع بمركز الأرض, we call it vertical. Now, the direction is always downwards. So weight is always directed downwards. على طول بدي فلت object بدي ينزل لتحت. هيدا الكونتريبيوشن اللي سموه لنا نيوتنز ابل عليه، انه وقعت التفاحة على راسه لنيوتن. So the magnitude of the weight can be measured by a dynamometer أكيد مثل أي فورس تاني. But it can also be calculated by a mathematical equation. وهيدي rule لازم نحفظها. So weight equals mass times gravity. Mass is expressed in kilograms, is the gravitational, it's a constant for a planet, and it is in Newton per kilogram. Together, kilogram, Newton per kilogram, weight will be expressed in newtons. So, هاي rule لازم أحفظها، وأهم شيء تنتبهوا إنه mass should be in kilograms. إذا شي مرة ثائب given mass in grams بنتذكر كلنا جرام to كيلوغرام نقسم على 1000. اوكي؟ اكيد فيك تكتبها باي mathematical way اريح لك. اوكي؟ So if I apply it here بالنسبة لل weight of the apple here, notice the center of the apple vertical and downwards. The value رسمته كيف ما كان because I don't have any value, so no need to worry about scales. Okay. Now, كنا حكينا إنه weight depends on a planet. In the equation that you can see here, weight equal mass times gravity. بتلاحظوا weight depends on two factors. The mass, so mass, the quantity of matter in an object, and the gravity, the gravitational attraction of an object to that, the rate of attraction. It's called the gravitational constant. Now, so each planet or celestial body, I added here because it can be a planet or a satellite or a star, anything, has its own pulling constant, in quotations, pulling constant, which is called the gravitational attraction or simply the gravity. For example, Earth has its gravitational attraction constant 9.8 Newton per kilogram or 10 let's say. يعني الأرض بتشد كل 1 كيلوغرام بتقريبا 10 نيوتن 9.8 أو 10. On the other hand, إذا بتروحوا على Jupiter, which is much more massive than Earth, هون الصورة مش كتير مبين الفرق. Huge, Jupiter is huge as compared to Earth. Okay? Gravitational attraction becomes 24.8 نيوتن لكل كيلوغرام. So تخيل كيلو will be pulled by 10 newtons on Earth, it will be pulled by 25 newtons on Jupiter. إذا بنروح على القمر, on the moon, gravitational attraction is much less than that on Earth. It's 1.67 بهالحدود. It is 6 times less than that of Earth. Now, summing these ideas together in one application, check this. We have an iron ball of mass 100 grams. It's suspended from the free end of a string, and the magnet is placed close to it. First, give the characteristics of weight. You are given G in 10 Newton per kilogram. Name the other two forces acting on the ball and specify whether each is a contact force or acting at distance. Give the point of application, line of action, and direction of the other two forces. اللي حكينا عنه ب2. 4. Draw the weight using a scale of 1 centimeter corresponding to 0.5 newtons, and the other two forces regardless of their values. يعني بدنا نحط الويت بvalue accurate. الفورسز الباقيين بس بدك ترسمهم showing direction and other things. So, take some time to solve this, and when you finish, check your answer with your teachers. I'm pretty sure that they will give you excellent insights about it. وإذا حدا بده الحل تبع هذا الاكسرسايز راح تلاقوه موجود بلينك راح نجرب نحطه ورا هيدي الحلقة مباشرة، بيكون كPDF فايل فيك تشوف الحل موجود معهم. نهاركم سعيد ويعطيكم عافية and stay safe again.